Welcome to Insight Builder channel, Python experts, programming enthusiasts, and my dear friends. Red Green Refactor your way to mastering linked list. In this video, we are going to work on a way of test-driven development. We are going to use a format called as Red Green Refactor. We will see this in action, and I will show you the steps to work on this particular method of red green refactoring. Install Pytest library by doing this pip install Pytest. In my case, I have already done the installation. If you go into the terminal and if you do a pip install Pytest, you will see that in my case it's already done. You need to create two files. You can be in any of the folders that you are working in, and ensure that you are creating two files. The two files in my case is going to be rgrlinked.py and test_rgrlink.py. The rgrlink.py is going to be the file where you are going to write the code for the linked list, and test_rgrlinked.py is where you are going to test what you are writing in the rgrlinked.py. So that is how you need two files, and then you have to start by the most basic test. Yes, you heard me right. You have to first write the test before you start writing the code. So this is the one of the challenging aspects of test-driven development. Like, you have not even started writing the code, then how will you actually write the tests? This was also one of the curious questions that I had, and red green refactor actually provides you the most basic way you can work upon, and be ready to be surprised, guys. I came across this red green refactor when I was reviewing the test driven development way of implementing hash map, and I will share the realpython tutorial link from which I learned this particular technique. And hash map that was implemented in realpython was pretty deep. It had lots of features, and the tutorial was pretty long. I wanted you guys to first of all get familiar and get comfortable with this concept of red green refactoring and doing the test driven development. So this is going to be with a simple linked list, and we will be implementing a couple of methods. You can go as long as you want with test driven development. It's I mean, it's like you are going to play the game with yourself, so you will see how this works in a couple of minutes. So let's dive in, and here you can see that the Pytest installation has been already done, and I already have two files here. I have rgrlinked.py, which is empty, and I have test_rgrlinked.py, which is also empty. I am going to start working on test_rgrlink.py. You can see that this particular file is highlighted. You can see that breadcrumbs also here. And let me zoom in a bit so you guys can see it better. I suppose this is sufficient. I am going to import the rgr linked list, and I'm going to import from rgr linked import node. So I'm going to first of all implement a simple node class to see. I'm going to test the simplest node class, because that is a building block of a linked list, right? So I want to instantiate a node. So for that, I'm going to write a basic test case, and the basic test case is going to be test instantiate node. So as you can see, the function, the test function itself is telling me what I am trying to check. And here what I'm going to check is I am going to assert that when I call node equal to, when I call node like this, when I instantiate the class, the assert should work basically. It should not be none or it should not be false. But in this case, when I'm going to execute this particular test, let's see what happens. I am going to do a CLS and I am going to do a pytest and dot. So when I place the dot here, this pytest is going to only check the current directory. It is not going to check the entire directory tree. So ensure that you are being very specific, or you can actually tell the test that you want to use. But I would suggest against it, because you might in the future use many different test files. So it's always better to have dot. So this is going to collect the test underscore files. So it is trying to collect test underscore rgr link.py, and you can see that it is in the red phase. So this is the red phase where we are getting the error. And here the error is that there is cannot import node from rgr linked, because if you go to rgr linked, there is no any input at all, there is no any data at all, or the code at all. So how to come out of this particular red phase? So in order to come out of this red phase, what we are going to do is we are going to initiate a node class. That's it. It's as simple as that. And we are going to say pass. We have not done anything. We have just created a class called node, and we are telling we are passing that particular class. And the moment we do that, and if we come and execute this, you'll see that the test passes. In fact, now we are in the green phase, but we have not achieved what we want, right? We have just taken a most basic step, that is we have created a node. So this flow of testing, failing, and correcting it is going to happen again and again. So let's go back to test rgr linked list, and now next what we are going to do is we are not going to create an empty node, correct? We have to create a node which contains a value. So how will you create a node? So you will give a value inside the node. The moment you give a value inside the node, and if you try to execute that, you will see that now it fails with a different error. Now it is saying that node takes no arguments. The node takes no argument because if you go back to rgr linked list, we have not given any kind of init method. So the idea here is that we have to create an init method. So let us create an init method, and inside the init method we can still keep the pass. So we are going to still pass the init method. We are not going to put anything there. So you will see that every line that we are going to write can be tested. So let us execute this right now. So we are moving out of the second red phase. So we are moving out of the second red phase, and now it has been passed, and now we have a node that can take the value. Next, what we are going to do is we want to, you can decide. So you might want to add an additional value where you want to check whether there is a next node connected to this particular node. So for that, we are going to create another one entirely different, or before we do that, we can actually do something very different. So you can try to give the attribute name called as val equal to a, and you can test that out, because even the attribute names matters. So in this case, before we do that, I have already given the value here. So let me actually change this. Let me change it to data. So I'm just changing it to some random word, and I'm going to execute this right now. The moment I execute this is going to fail again, and this time it is going to fail for a different reason. It got an unexpected argument called as val. This error is coming because the node is expecting a value called as data, but when we are testing it, we are giving it a value called as the attribute called as val. So because of this, it is creating the error. So you can go to rgr linked list and we can correct it to val. And the moment you correct this, and if you go back and execute the test, it will execute and it will not fail. So now you understood that each and every part of the code, each and every changes that you make to the code can be tested like this. and you can ensure that the final the framework that you are going to create, the test framework that you are going to create, checks each and every aspect of your code that you are writing, the algorithm that you are writing. So let us continue in this fashion. So next what you are going to do is we are going to test whether the node has got the next whether the node has got next node. So it has to get a additional node connected to it. That is how we can use it in linked list. So we are going to say test next node, and in order to test the next node, we have to first of all instantiate a node, and then we have to instantiate it as val equal to a. And what we need to do is we have to assert. So we are going to use simple assert only, and we are going to assert x.next. And the moment we do this, and if we execute the test, you'll see that it fails again. Here it says that node object has no attribute next. So you know what we need to do now. So you go in and you start by creating the next node, and you can assign it to none, right? And also it's better that you will start by assigning the value also to the node, right? So you have done that. Even this step that I am doing here, I'm actually skipping it. You can actually test that out also. You can take baby steps and you can test that out also. Now if I execute this, you will see that it will still throw an error, because we are actually getting assert equal to none. So when something gets asserted as none, what will happen is it will throw an error. So how are we going to work here? So I have to either give a value to next, but in my case I will not be able to give, because that's how the node has to be initiated. So we are going to assert not none. So basically we have to assert that. So if there is something the value is given initially for a particular node, then it is wrong. So we don't want that to happen. So then we have to do the opposite. You understood, right? We don't want the self.next attribute to have any value, and we want to ensure that when the node is created, it is in such a fashion. In order to ensure that it is done that way and the code is written, I mean the code is developed that way, we have to assert it as not x.next. So let us see how this comes out. So let us execute this. The moment you execute that, you'll see that this particular test also gets executed without any failure. Next, what you are going to do is we are going to try and get the print output of this particular node. So we are going to try and print this node, and we need to capture that output and test it. In case of when we print the node, this particular node, for an example, the output should be simply the character A. We don't want any other output. We don't want the object memory, etc. We don't want that. We just want that value A. So what we are going to do is, so we are going to say test print node, and once we do that, we are going to instantiate the node again, new node. So every node that you are going to instantiate here will be new nodes. It will not be linked with any other node. If you want, you can use fixtures, but in this case I am not using the fixtures because I want to keep it as simple as possible. And the dry principle also, it's not used here. As we are learning, don't worry about the these kinds of nitty-gritty details. Go with the regular flow of doing it repetitively, and later you can implement any kind of automation on top of it. Next, as I was telling you, we need to capture the output. So how are we going to capture the output of the print statement? Because see, what will happen is you will do something like this. You will say print x, correct, and the output will be printed on the screen. It will be printed on the terminal. How are we going to capture that output and then check what is the output inside the test? So for that, there is something called as capsys. So capture sys. So you can call this module from inbuilt into Python. You can call that, and you can use that to capture the output. So you can say captures, and you can say capsys dot read out error. So you have to do this, you have to call this method, and once you call this method, you can now assert the captures output. So you can say captures dot out is equal to a. So this assert will work. So let me also print out what this captures dot out contains. So let us do that so you can see what's going on. So captures dot out, and let us execute it. So anyway, it's going to fail, but I just want to execute it and show you what happens first. So now it has collected 3 items, and you can see that it is not having a, and the captures dot out equal to a is failing. So this is the error that is coming out. So we go to the RJR linked and we start implementing the dunder str method. So that is how you are going to print it. So I call dunder str, I create dunder str, and I say self, and I'm going to return self dot val. So that is how I'm going to do that. And once I come back here and once I execute this, right now this will execute. Okay, there is an error here. What is error? So you see that whenever I'm going to get the output from the print statement, it is going to be with the /n. So you have to assert that the output is going to be with the /n. You understood what I was trying to say, that if you are going to print the values in Python, it is going to be attached with the /n, that is new line character. So go back to the test, and in this case you have to modify the test itself. It's not that you are going to modify the output. That's not going to be modified. You have to modify the test. So you are modifying that, and now you are going to execute this. I will see that it passed and it worked. Also, one point that I wanted you to look at is that we tried to print this, but in our output you are not seeing that print value. This is because the way the test works is completely different from the way the code gets executed. If you go up, in case when the test was failing, you were able to look at this particular a value, and there was a new line also. You see that there is a new line. That new line is because of this new line character. But this is not very clear. So what you can do is you can actually write something like this. So looking at capture, and now let us make the test fail. So whenever you are trying to learn the ropes of a particular language, it's better that you try to print as much as possible and see what exactly happens. Especially when you're doing this test-driven development, you can see that here. So you can see looking at capture a, and after that there is a new line character. So that's what I was talking about. And once you correct this test, that will be gone. So till now we are only working on the node only. We have not even started working on the linked list, and already 20 minutes of time has passed. So how much time it is going to take to implement the linked list? See, if you are quite comfortable with the test-driven development, see, you will take maximum, if you want to implement the entire linked list, it's going to take around 30 minutes of time with all the methods and all the tests also. So let's continue further. Another 10 minutes we will be able to do it. So now what we are going to do is we are going to test instantiate linked list, LinkedL. So that is what we are going to test it now, and assert. We are going to assert linked list. So this is what we are going to assert, and I have not done anything. So you see that I did not import the linked list. I did not write the code, and I am blindly running this test right now, and you'll see that the test is failing. So the fourth test, let us do this, 1, 2, 3, and the fourth test. The fourth test is failing. So that is because that the linked list is not present. The error is that linked list is not defined. So how are you going to make it defined? So you have to first of all import it from the RJR linked, and even after you import, you will actually get the error that RGR linked does not have the linked list. So for that, you go into RGR and create the linked list class, and all you are going to do is pass. You are not going to write any code there, and even if you don't write any code, what will happen is the test will still pass. But now that is not sufficient, right? We want the linked list to have something. We don't want it to be empty. So for that, what you're going to do is we can actually modify this linked list, and we can try to check whether the linked list contains something. So what will the linked list contain? It has to contain a head. And whenever we are trying to implement a linked list, we want the head to be none. Again, we don't want the linked list when it is instantiated to have any values. It can be empty also. It is acceptable. So if that is the case, then what we do is we simply move down and we create one more test. We say test check test head attribute. We can say linked list head attribute. Okay, with that said, what we are going to do is we are going to create a linked list, and that is how we create it. And then we are going to assert ll dot head. Now this is going to be again a negative assertion, so the head is going to be none. So in that case, we have to assert not ll dot head. So this single line is going to check that there is an attribute called as head, and that attribute should not contain any value. So these things it is going to check, but this is going to be also contradictory. You will see how to come out of this in a couple of minutes. So let us save this, let us execute, and now you will see that the test is failing, that the LList object has no attribute head. So let us go to the code and let us implement that. In order to get the attribute, you have to create the init statement, and you are going to say self.head is equal to none. And once you implement this, go back and do the pytest dot, and you will see that the test passes. Now comes the tricky part. You don't want the head, the linked list to be empty always, right? You want to attach or append something to the linked list. And in order to append something to the linked list, you have to first of all know what you're going to append. So to the linked list, you can only append a value. And once you are appending that value to that linked list, it is going to become a node. So it's kind of, the process is done inside the linked list. It's not done outside. Let's go back to the test RGR linked. Here we are going to say def test append LList append value. This is what we are going to test right now. So in order for the value to be appended, LL is equal to LList, and the list is going to be empty in the beginning, and then we are going to assert LL dot append val, and inside the val we are going to give a value called as a. So that is how the appending has to happen. That is a specification that we want to be implemented, and we are going to execute the test again. So this is done in the test. So you see the flow that is happening. So there is a red case, then we modify, we do the refactoring, and then we get the test to become green, and this flow happens between you and yourself. As I was telling you, it's a game between you and yourself. The more you understand the basics of how each and every line of the Python code works, the faster you can implement, and finally you will have a lot of tests in front of you. And also you will whenever you are going to modify any kind of feature, you will be first modifying the feature inside the test first, and then you will be modifying the feature in the code. So in this way, what will happen is your test will be written always first. Your test will fail first, and then you'll write the code to correct it. So the next couple of minutes, I'll be writing the entire linked list along with the functions, and then I'll be starting the video again. So I'm pausing the video right now. So I have written the code for append val method and inside the LList class, and you can see that whenever the logic is pretty simple, that if the head of the linked list is none, then we are going to add the value node to the head directly. If the head is not none, then we are going to traverse and find where there is no next node, and then we attach the new node to that next node. So that's what this while loop does, and then we are returning none. So whenever you are just clicking, whenever you are just giving this kind of return empty statement, what happens is it is going to return none. Because of this, even though the activity has been done, even though you have completed your appending process, if you execute the test will still fail, because the assertion error here, if you see, we are testing if you scroll down, we are testing that assert ll.append value, and we are trying to append this. And if this becomes none, it means that the appending did not work, or there is some problem in this method. So in order to make this test pass, you have to come here and you have to return true. Only when you return true, that test will pass. Just a second. I'm saving it right now, and yeah, I'm going to execute this. The moment I execute this right now, it passes because it is appended and also it is returning true. If I don't return true, then it will not work. So as you saw, that by using the basic methods, basic red-green refactoring, using the red-green refactoring test-driven method, we have started writing the node, and we have started writing the linked list, and we have started appending the value. You can also do the basic checking in this particular script itself. So here you can start writing a simple test case where you say, let us say temp is equal to this is his wallet, and what you can do is you can try to append all the characters into a linked list. So you can create a linked list here, ll1, and you can say linked list. So this is also one of the ways. There is nothing wrong in doing this. So you can say for c in temp, and you can ll1 dot append val, and in the val you are going to append this. And once you do this, you can execute this particular script itself. So you can say Python, and you can execute the rgr_linked.py, and you will see that none of the output came out because the appending happened and this particular process completed, but you don't know what is exactly happening. You are not actually getting any kind of feedback. You can try to write one more test case where you try to print the values. So you can actually do this way. So you can say print list, and you can write the code for printing it. Just give me a second, I will complete the code. Let me type it. So if we are going to store the value somewhere, if self dot head is none, then we return empty. That is what we are going to return if it is none. And if so, all these things, whichever point that I'm writing here, you should actually first of all write the specification inside your test rgr linked, and then only you should write the code. But here I'm showing you another one way of testing. If you don't want to go through the rgr linked list option, this is another one option that I'm showing where you can get the feedback, because testing is always about feedback, right? So current is equal to self dot head, and while current dot next is not none, that time what I'm going to do is I'm going to append the value of the current dot value. So let us make it a string, because it can actually contain other object type also. So let us typecast it to string, and then I am going to move the current to current dot next, and then once it comes out I am going to append the last current dot val also, to ensure that I'm not missing the last one, and also to ensure that there is some space between all these values. I'm going to give a space here. I'm going to append that, and once that is all done, I'm going to print it here. So this is very important. I'm going to print the stored value, and then I'm going to return. So I'm going to return true. So it has run through the entire process. So I'm going to return true, and let us go back just a second. Scroll down, and here if you run the ll1.print here, print list here, it should return empty, and if you run it here, it should return the entire list of values that is pushed into the list. So let us execute this right now. So you will see that there is an error here. So initially I executed this rgrlink.py and I am only getting h. So what happened here? Let us debug. So this is one of the challenges I was telling. I typed it so fast and I did not even check any of the logic. I did not care what is the output that is going to come, and I immediately pushed it. So this is one of the challenges that you might also face. So it is always better that you write the test and then you check it and ensure that all the tests are passing. So first, why this ll1.printlist did not print? Because I did not actually print the return value. So you have to enclose this particular ll1.printlist inside the print function. So that's the first thing. So let us execute that, and you'll see that this particular line is getting executed. So till this line it is all working good, and then it scrolls down, and this area also the things are getting passed, but I'm still not sure whether the issue is in the appending or whether it is in printing. But what we can see is it is actually printing the h. So there is only one value, that is h, from this his wallet is getting printed. So what is happening to the rest of the values? So one of the possible issues is that when I am trying to run through this loop, assume that I have appended h. So the first value is h from this character, from this string, and it would have got appended to the head in the beginning. When the loop comes the second round, when I am trying to append I, it would have checked whether there is self.head. There would have been self.head. It will not be none. So the current will be self.head, which is h, and it would have tried to enter this loop. Now what would have happened here? While current.next is not none, but in this case the current node is self.head and the current.next is none. So basically it will not enter this loop at all. That means it will actually come to this step, and whatever value I am trying to push into, it will be coming into this value. So this is actually going to create a problem. So I need to try and place current.next here. So in this way, what will happen is whatever value I am trying to push will be getting into the next node. And once that simple modification has been done, and once you execute that code, you will see that his wallet is getting printed, and you will see that there is a double space here, because that double space has been caused because of this additional space. And the final one, there is you don't see the space here because it's ended. So that's how you actually do a different kind of a test, by using your single script itself. You can also try doing the same thing. Try to write the print list by using the RGR, that is red green refactoring process, and you can add almost 3 to 4 more tests in this list. It is possible to add that many tests for this print list method. Let us go back to the presentation. So I believe that in this discussion, you not just tried to work upon the data structures, you also tried to learn how to use the test-driven development way of red-green refactoring and implementing your linked list data structure and testing it hand in hand. So it was actually, you know, like playing a game where the uh, where your logic and your ideas were getting tested time and again. And finally we completed the linked list, we implemented the methods. Like this, you can implement any number of methods, any number of features, or any number of modifications that you want to make, and all of those things will be crystal clear to you always. So I believe that you have learned a thing or two from this video. Do leave a like and share it with others. Most importantly, subscribe to my channel for further updates on similar kind of discussion. See you till the next time. Practice, practice, test, test.